In this video, I'm going to show you how to get started with GeoPandas. If you have been following my tutorial series about this course, and in the past we have been building this package and added functionalities from other packages. So in this video, I'm going to build on top of GeoPandas to provide some functionality that allows you to read data and also display data on interactive maps. So if you have not heard about GeoPandas, it's basically an open source Python package for dealing with geospatial data, especially vector data. It can pretty much deal with any type of vector data that you commonly use. For example, Esri, shape files, or Geojson. So those are some of the common formats that you might be using. And so first, let's go to the website to download the notebook example that we're going to use here in this video. Go to the geodemo.geosoft.org and then click notebooks. At the bottom here, GeoPandas. Then you can click the upper right corner here to download this notebook to your computer, to any directory that you want, and then click save. Then you can open the directory. But before we open the notebook, we need to create the Conda environment. So here I have the instruction. You can go through the instruction. You can also look at some of the outputs from this Jupyter notebook. For example, you can create some nice maps that you can use to for example, peer-reviewed articles or reports. You can also create interactive map. The IPyLib doesn't show up here on the notebook, but I'm going to show you later how to use this. So before we get into the details of this notebook, I would like to point out that if you're using Windows operating system, it might be challenging to install GeoPandas. Also, if you're trying to incorporate GeoPandas as a dependency for your package, you need to be careful, especially if you're hosting your package on GitHub and using GitHub Actions to build and deploy the package. You need to make sure that you make some changes. So first, I'm going to show you how you can incorporate the package into GeoPandas into your package. You need to add GeoPandas into the requirements.txt, right? So for example, if you on the using Visual Studio Code or whatever editor that you use, then you can add GeoPandas. But keep that in mind, once you add GeoPandas, if you have GitHub Actions, so for example, for me, I use GitHub Actions and then workflows, build. So from here, make sure that you comment out Windows, because all the GitHub Actions here use pip to install the packages. And if you're on Windows, don't use pip. You won't be able to install GeoPandas using pip, because it has some C library dependencies. And for example, GDAL and GOS, those are very difficult to install actually on Windows. So you will need to comment out this one. Otherwise, when you're trying to push your package to GitHub and then use GitHub to automatically check the package, it will fail, just like what you're seeing here. You need to remove this one, otherwise it won't work. If you look at my example, right, I failed a couple of times because GeoPandas just doesn't work well on Windows using pip, and there are always some issue that you might run into. So I want you to be aware that if you are trying to incorporate GeoPandas into your package and trying to use GitHub, you need to make sure that you follow the instruction to include it in the requirements.txt, but also comment out the Windows operating system. Linux and Mac computers, they work just fine, so you can leave this as it is. Okay, so that's something you want to know before we get into the detail about notebook. So next, let's go to notebook example. And since we already download the notebook example, then you can open an Conda prompt. So you can open your terminal. So for me, I'm going to open my Windows terminal. Then, so the next step is to create the Conda environment. Also, you can click the link here to go to the GeoPandas webpage to look at more tutorials and instructions how to use that. It's very, very powerful. So most likely, if you're in the open source geospatial community, you might have encountered GeoPandas. So this is just a video show you how to get started. There are a lot more things you can do. I might have another tutorial series in the future to introduce GeoPandas, but it will be just a simple introduction in this video. Okay, so next, let's create a Conda environment. Make sure that you follow here exactly this command line, because otherwise you might run into any issues. Okay, so first you need to create a Conda environment, and then create using the Python 3.8. Don't try 3.9 because some of the packages are not available for Python 3.9. So don't do that for 3.9. So just copy and then right click, paste, hit enter. Okay, so create the Conda environment and install Python 3.8. It's be done. Then you can Conda activate, copy again, and then come back here, activate Conda Geo. Next step is to install GeoPandas. So you want to use this one. This is basically from the official Conda channel. Don't use the -c and Conda first, because from my previous testing, it has some issues. So you want to just directly use this one. Don't try the Conda first channel to install GeoPandas. So this one, it might take some time, but usually it should automatically resolve all the dependencies and then install GeoPandas successfully. Okay, so this is a good sign. And then just type Y, hit enter. It might take some time to download all the packages because I already installed that one before on my computer. All the packages might have some cache on my computer, so it will just retrieve those packages directly without having to download those again. And next step is to install some other packages. For example, Matplotlib. That's the package that we need in order to do the plotting. Also, the Geo demo is the package that we have been building, and so that one we're going to use to create interactive map and display data. So all we need to do is just copy and then right click here, paste anyway. Okay, so it might also take some time to resolve all the dependencies. Once it's done, then we can install all the packages. Okay, nice. So tap Y, enter again. It might take a couple seconds to download all the packages, and once it's fully installed, then we can start doing coding. In here, you can look at the right here, we have a couple sections, right? We can, using GeoPandas, you can pretty much read any vector data because it utilizes this C library to read data and write data. So it has a lot of functionalities, but in here we just use some simple format, for example GeoJson or Shapefile, but you can apply to other vector data as well. Okay, so once we have installed all the packages, then we can just type Jupyter Notebook, hit enter. It should open Jupyter on your within your browser. Then just click the notebook. Okay, so in here you can click the table content to take a look. So we have already finished the first section. Then we're going to import the library. So in this case, we need the Geo demo later for creating interactive map and also the GeoPandas. So usually the convention is to import it and then use GPT. Okay, so next we can read some data. Here, one nice thing about GeoPandas is that you can read data directly from the internet, also from an URL. You don't have to download the data to your computer, so you automatically retrieve the data and read the data in a format that can be recognized. So this one is from my GitHub repository, the Geo demo. You can go to my GitHub repository here. I provide some sample data. So under the examples directory data, you will be able to see some sample data here. And in this video, we're going to use, for example, the NYC neighborhood, New York City. It has a GeoJson, but it also has shape files or a zip file. So in this case, we're just going to use the GeoJson. Keep that in mind. If you click the link here, don't copy this and trying to read this URL. It won't work, okay? Because this is not the direct link to this data set. It's still hosted in GitHub. So if you want, you need to make sure that you click this one. Click the raw button or right click and then copy the link address, okay? Don't copy this one. That's the that's not the correct one. So if you click the raw button, and then so this is one actually the simple plain txt file. And then you can copy this URL, come back to the Jupyter notebook, and you can paste the link in here. Okay, so this is the correct one. And once we have the URL, we can use the GeoPandas .read file function to read the file. So this URL here, it can be HTTP URL. It can also be a file passed to the file on your local computer, for example, depending on what operating system you're using. In this case, for example, if you have some sample data here, and then you can just copy this one, and from here you can just paste the URL here into this function. So we're just going to use the example that we use. Once you read the file, it's stored in the Geo data frame. So basically it's just like a spreadsheet that with every row has one record representing one geometry, and it has a geometry column to represent the shape of the object. Okay, so if you want, you can just directly type this one and it will show you the result. As you can see, right, we have multiple columns, so you have different attributes, but you also have the geometry column. So the geometry column is the one where store all the coordinates for that specific object, right? So in this case, we have 129 rows multiplied by 3 columns, right? 1, 2, 3. If you want, you can also show the coordinate system, right? So if there's a geo data frame, then you can just use .crs. It's going to show you the coordinate system. So in this case, it is EPSG 26918. So this is UTM zone 18. If you go to this one here at the beginning, because this is a Geojson, right? It's essentially a dictionary, so a feature collection. It has a CRS key, and the key within here you can find out. Okay, so it has the EPSG number 26918, right? So this is how you can read the data. Once you read the data and store it as a Geo data frame, you can also save the data to other format. For example, although we read this one as a GeoJSON, you can also read a shapefile or other vector data format. Then you can just use the to file. So the to file is to actually save the data to your computer and using other data formats. So the driver is the data format. There are many supported data formats. So in this case, we're just going to use GeoJSON and to save this one to a computer under the data directory. And then this one, if you direct run this one, you might run into errors because you might not have the data directory on your computer here, because I'm under my downloads folder here, and the download folder right now does not have a data directory. You can either create a data directory here, or you can just simply change this one here. I'm just going to delete the data folder and then run this one again. You should have the file right now on your computer, right? So this is the one, and once you have the file, you can keep this one on your computer, or you can move to any other directory you want. Okay, so this is just one way that you can read the data and write data. Very simple and easy to do. So for read data, just read file. Write data, just to file. Also, if you want to look at the function definition, press Shift tab on your keyboard to bring up the function definition. So here you should be able to find out, for example, file. You can also pass in the bounding box or a mask, and a lot more parameters you can provide, right? So here you can look at the information, and okay, you can also look at the example here for more details. Okay, so this is about how to read and write files. Next, I'm going to quickly show you here, because this example is a polygon data set. So you can easily measure some area. What you need to do is to use this one. So we can create a new column, and the column is named area. Then we calculate the area for each geometry. So we have 129 geometry, right? Basically, we have 129 polygons. We can calculate the area of each polygon, and then assign the area to a new column with the column name area. Before we do that, we might want to set the index because once we want to display the result, if you don't set the index, by default it's just going to show here like index 0, 1, 2, 3 all the way to the total number of rows. And usually we want to set the index to a unique number that we want to display. So in this case, it will be the name column, right? So because the borrow name column, it has duplicates, right? So this one is unique. So the name, we want to use the name as the index. What you need to do is just to try this one, GTF.set index, and then the name of the column. That's it. After that, you can run this one. So now you can see we calculate the area for each polygon, and then we can display the result. So this is the name, this is the area, and you can see the result for each one. You can also get the boundary, right? So in this case, the boundary basically is the line, right? So if you have polygon, then you can have the line. This one returns as a geometry type, right? So you can see a line string and also the vertices for that polygon. So basically, this is just simply if you're using ArcGIS or QGIS, it's just convert polygon to line. That's it. And you can also get all the coordinates for each vertices. Similarly, you can also get the centroid. So all you need to do is just apply dot centroid. It's going to get the centroid for each polygon, and then you can assign the centroid to a new column. Then you can print out, right? So similarly, this is just one point, just a single point. Once you get all the data, and if you deal with measure the area, for example, the length, or get the centroid, you can also create some maps. The simplest function you can use is just gtf.plot, right? So the gtf is the geospatial data frame, and if you just by default, you don't need to provide any parameters. It's just going to show you this one. So by default, a small plot. And this is the polygon that we use, right? The NYC neighborhood. You also notice here we're using the UTM zone 18. So this is not longitude and latitude. I'm going to show you later how to convert that one to lat long. But for now, this is just a simple map. You can also customize to make it look better. So for example, you can customize, you can plot the map based on a specific column. Earlier, we already created the area, right? So now the Geo Data frame has an area column. If you want to see like how many columns there, you can just GTF and then Shift Enter. You should be able to see the columns, right? So this is the first, second, and the third. Those are the three original column, and then we also calculate the area, the boundary, also the centroid. So we can plot the map based on this area column, and we can also add a legend. You can also customize the figure size, because this one here is a bit small, so you might want to change it to a larger one. So 10 and by 8, and just right. So 10 by 8, similar to, looks like something like this. So it's much bigger. And this one here, the area, so the size, the color represents the area. So the yellow color represents a larger area, blue color represents smaller area. So this is for each neighborhood. As you can see, we plot by a specific column, and you just need one line of code. You can create some nice map like this. So pretty easy. Also, you can, for example, set the geometry. So in this case here, this geo data frame, right? We have multiple geometries. So this one, earlier we used this one because it's a polygon, but you can also set the geometry to others, for example, to a line or to a point, right? It doesn't, if you're using a shapefile, you can only have one geometry column, but if you're using geo data frame here, you can actually specify which one you want to use as the geometry for that specific object. So we want, for example, to set the geometry as the centroid, and then similarly we can plot by area. So in this time, it's going to show you just the point, right? Because although it's still the geo data frame, but the geometry has been changed from polygon, changed from this column to this one, right? So now you only see the points. You can also plot multiple layers on the same plot. For example, this is the geometry. Right now, this is the geometry. This is the polygon, and then you create the polygon. Then you also add the centroid to the plot. And if you execute, right now we have two data layers, right? So the polygon at the bottom and the point layer on top. This is how you can actually plot multiple data layers. You can add more, as many layers as you want. So lastly, once you're done with this, because this one is still a polygon, so if you change the geometry, you might need to set that back so that when you read the geo data frame, it's still treated as a polygon, because if you set to a point, then it becomes a point. So the last line here is to basically return the geometry, to set the geometry so that the geo data frame right now is a polygon, right? So this is how these are all the built-in functions by GeoPandas. Next, I'm going to show you how to display GeoPandas data on an interactive map. Again, we're going to use the same data, and we're going to use the Geojson data NYC neighborhood, and then so we're going to do the same step here, provide the URL, and then read the file. In order to display the data on interactive map, for example, iPi leaflet, we need to convert the data to coordinate system, so longitude and latitude. You can do that by dot to CRS, so to CRS, and then provide the EPSG 4326. So this is the leg long WGS 84. Once you convert this one, you will be able to see, for example, we convert this one and then we save as a new data frame, and if you control enter, you should be able to see this new one. So now you will see here, this is the longitude and latitude, right? So longitude and latitude compared to the earlier one that I show you here. This is the UTM zone, so this is by meter. The number is different. So most of the interactive map use lat long and WGS 84, so it might not be able to display this kind of a custom projection data directly. So we need to convert this one to lat long. So this is what we are trying to do here, and very simple. Just dock to CIS and then EPSG, then you can display the data. Once we have basically this is the data reprojection. So once you reproject the data, you might want to get the Geojson for this, because in order to display the data on the map, we need to get the Geojson from the geo data frame. So what you can do is to doc underscore geo underscore interface underscore. So this is basically an attribute that you can retrieve the Geojson representation of the dataset, right? So we can just alt enter, and then if you want to see what's inside, you can just print out this variable name, and then shift enter or control enter. You should be able to see the result. So this is a long file. You probably don't want to display that directly on this notebook, right? So each one here represent one polygon, and also has the bounding box, also the ID, right? So what we need to do is to get this Geojson so that we can display it on the map. Okay, I'm going to comment out this one and run it again. So lastly, once we have the Geojson, then we can add this one to the map. In the previous videos, I already showed you how to, I think, use Geojson, for example, with iPi leaflet. You can look at this video. And so once you know how to use Geojson with iPi leaflet, then you can directly display the Geojson data from GeoPandas, and then to show it on the map. So first, let's create an interactive map. I'm going to create use the geodemo doc package. You can also use Gmap. It's more complicated, but the geodemo is the package that we have been building throughout this tutorial series. So it has some limited functionality, but if you want to use the full function about doing cloud computing, then you can try out the Gmap Python package. Okay, so first let's create an interactive map, and then we can set the center. So this is latitude and longitude, and then set the zoom level to 10, and then we can display the map. So this is right now just an empty map with Google Maps as the background. Behind it also have open street map. Once we have the map, then we can set the style, because eventually we're going to use the GeoJSON function, and we can pass in the GeoJSON that we retrieve here from this Geo interface, and then we can set the style. You can change, for example, the opacity. You can change different color, whatever you want, and you can also set the layer name. So the layer name we can just use, for example, NYC neighborhood. So I'm just going to execute these 2 lines. Now you have this data here directly on the map. So this GeoJSON come from the URL that I provided, right? And then we read this URL using GeoPandas, and then convert the projection to a coordinate system, latitude and longitude. Then we retrieve the GeoJSON as a dictionary. Then we can just pass in the dictionary as the @GeoJSON function from the GeoDemo package. And this is kind of a general procedure how you can load the data into an interactive map, right? You can zoom in, you can zoom out. You can also turn the layer on and off. So this is just one simple example. If you want to load more data layer, you can. So the next example I want to show you is to use the NYC subway station, so as a zip file. So this one here, the zip file contains there's a swap file, right? So it's from my again from here, data, and then NYC subway station. So as you can see from this one here, we have .ssp, but you cannot directly use GeoPandas to read .ssp from a URL, because it has to have multiple components. So if you want to read that from the internet, you need to compress them as a zip file. So in this case, this is the zip file that we are trying to read directly. Again, don't copy this URL, it won't work. You need to click here, the download, right click, and then copy linked address. So this one will work. And then you can come to notebook here, and then you can paste this URL. So this is the URL that you can download the data, use GeoPandas to read the data. Okay, so I'm going to execute. So within the zip file, it's a swap file, and then we can again use GeoPandas to read the file. After that, again, you need to convert this one to geographic coordinate system 4326, right? And after that, we can get the GeoJSON, right? Once you have the GeoJSON, then you can add this one to the map. Okay, right now this is the point layer. Again, you can just shift enter. You're supposed to have this one, right? And then you can zoom out, you can zoom in. This is just using the IPy leaflet markers class. You can, if you have too many points, it might be too crowded. In that case, you can use the marker cluster. So you can try the marker cluster. If you want, you can also look at the example that I provided here. I think might be under the IPy leaflet marker cluster. So you need to do some coding, but in this video, just showing the simple example directly using a marker. So these are all the NYC subway station. You can zoom in to take a look, right? So most of the points are basically this subway station here. You can also load, for example, lines or other polygon data layer, but in this example, I show you how to do that for GeoJSON and also from a zip file simultaneously. If you have some data stored on your local computer, you can also load the data directly. So all we need to do is just use GeoPandas to read the data and then convert the data to geographic coordinate system, and then get the GeoJSON. Then you can add the GeoJSON to the map. That's it. So that's kind of a general procedure. You can also turn the layer on and off. Okay, so that's pretty much what I have for this video. I hope you find it useful, and I will see you in the next video. Take care. Bye bye.